Let's begin. Thank you for coming. My name is Pedrazas. I work at Docker, and today we're going to talk about building agents. So this is me, and I make agents when I'm not doing Docker things. So if you don't have time or you have to leave, this is the TLDR of the talk. We had to build a lot of stuff to build the agents and all the stuff that we have done. I'll show you a lot of the things, and we had to build a lot of tooling. So let's start with one of these questions. What does AI brings to the table? Why are we doing AI like the way we're doing? And it's mainly two different things. One is augmentation, and the other one is acceleration. So we can do more and faster. OK. But is there a limit? Can we just keep doing it more and more and faster? So I went to one of these agents and I asked this question: can we use the Hamiltonian in my AI agent, blah, 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 and it responded. And it responded a lot of stuff. I think that is here, I can show you. It responded a lot of things. It's like, OK, there's one thing that talks about surgery. Yeah, robotic surgery assistant. Not my kind of thing, but it's kind of thing. So what is the issue with this? That I don't know if what the agent is saying is true or not, good or not, right? So my knowledge is my limit, right? This is it. The limit is not how much it can do, it's how much you know. To understand that there's not taking the piece. So let's talk about the journey that Docker did with AI. We started a while ago. We started, I think that it was in DockerCon in LA, we announced the Gen AI stack. And, well, we've been very busy. I'm sure that you're familiar with these kind of questions. We need to do AI. We need to add AI to our products. Are we doing anything with AI? Are we releasing that AI thingy? And for us, one of the main beginnings is a Docker file, a really bad Docker file, or a lot of bad Docker files. We analyze GitHub, and we found the people don't tend to improve Docker files much. So then if you basically put that information into an LLM, the suggestions you're going to get are not great. So as I said, we started with the Gen AI stack. We had Ollama using Compose, and it was OK. But then we started poking and trying to do things, and we end up with, we're going to build our own agent, which is called Gordon. And for those who know, Gordon was this tortoise, that it was a mascot of Docker. This is Gordon. I can show you. What is my Gordon? Gordon, here we are. Same question that I ask. Right? It's like you can go and ask any kind of questions. It has tools. So we have all the tools that MCP provides and blah, blah, blah. Right? So it's an agent, an AI agent, because we felt that we needed that to deal with the bad quality of Docker files that we had and help people to do better things in Docker. Right? And in this case, what I asked Gordon was basically, I have this repo in GitHub. Can you go and suggest labels I can use? I'm one of the maintainers of MCP registry. And it came back and suggested all these labels. Right? It's like, OK, good. Let's see if I can now implement them. Right, so we started, when we were building Gordon, we started thinking like, OK, do we host our own model? Do we use something? Do we know how to do it? And it's about keeping the focus of what we wanted to do, right? I built this kind of framework when I was in Docker Labs, which is basically about problem, hypothesis, and validation, how you can keep focus on what you really have to do. But at the end, when you're building agents, you end up building things like it's like classic, like you're doing platform, you're doing the application, or you are doing dev tooling. Right? Like for agents, it's very similar, but we have the agent per se is an interesting aspect. So this is the journey that we have. We have the GenAI stack, then Gordon, then we built something called Docker Model Runner to be able to run the models locally, and then we started doing MCPs, the MCP catalog, the MCP gateway, and then we create something called Agentic Compose, which is primarily what, if you are building an agent or you are starting building agents, my advice is to go there and check it out. Because we basically had this thing in mind. What, me as a developer, do I need when I need to create an AI agent? And then, I think it's here. It has a lot of examples for very different frameworks. So A2A, Agno, CrewAI, blah, blah, blah. And you can come here and it's a compose file. Right? I'll show you a little bit more later. What has happened now? Okay. So we have compose, and now from the service that you have agents as well. You have the models, you have tools, you have secrets and volumes. So you have what we used to have with compose, but now you can do it building agents. This is one of the best examples, the sock shop that we've created, because it has a front end, it has a catalog, it has a DB, and then has all the agentic stuff, right? Like the UI of the agent and the gateway. The gateway is something that we have created to be able to manage this tooling, all the MCP tools, the models, and the usual stuff. Okay. So one of the first things that happened at Docker was that someone said, like, we need to standardize tooling. We just want to have one or two IDEs that have AI. It didn't go well because we don't like to be told which tools to use. We are very particular. By we mean developers. The other thing that happens is that you need hardware. And these machines that we had were not enough. If you don't have GPUs, then can you do it? Yes. But can you fish a shark with a dinghy? Yes. So what is the difference between local models and hosted models or SaaS models? It's a little bit like driving a car or having to build a car. Or if we talk about databases, it's about knowing how to install and configure and operate a database. But still, you have to know which database to use. And this is something that a lot of people are very confused with the models. There are models for text, there are models for images, there are models for coding. Depending which model, depending what you want to do, you have to choose. So you might have to have 3 models, right? It's one of those things that we see that people struggle a lot with. So there are different ways of running LLMs, Ollama, the Model Runner, LM Studio, and so on. Right? You still need to have your hardware. You still have to be able to do it. And the other thing that you need is basically a way of running workflows. The majority of people, usually, when they talk about building agents, what they're talking is about building workflows. But that's it. Again, there are tooling that allows you to do it better or worse. It's important to understand as well, like, one thing is to do it for development for your machine. The other thing is to do it for production. Right? It's like one thing is I'm going to run, and in my home lab, I'm going to run it in my cluster. Right? It's different things. So be aware of this. And this is the quote that Marshall McLuhan said, is that we shape our tools, but then tools will shape us. And this is because you will start doing things. And then you will do things with the tools that you have, because you have them. It takes a lot of time and energy to learn all these new things, right? So then someone will say, pick the right one. Easy. Right? It's like, yeah, making the advice of pick the right one is very simple. But there are a lot of variables that we don't know, right? So it's a much better approach to go is like, I'm going to drop it. I'm going to do something, and if it works, great. And if it doesn't work, I'll drop it. And by dropping the tools, I mean all the things that you're going to build. And you're going to build them. Right? So when do we need an agent and when do we need a workflow? That is something that it's important to understand. And you can roll the dice, but you can start asking questions about who is the user? Who is the user in an agent? Right, like we talk to the agent, and then the agent does what? Because the key of the agent is that it's autonomous. It's going to make their own decisions. Right? So coding agents, great. What do? Well, they write code. Right? Agents will go and do whatever the user tells them to do. But you cannot plan. You cannot say, oh, we're going to use Go or PHP or JavaScript. If you do that, it's, again, we fall back to the, let's try to find one or two IDEs. People don't like that, right? So one of the things that we had in Gordon was a way of optimizing your Docker file. But then we realized that maybe people want to change that and do their own thing. Right? Like that is kind of a workflow where you have to make certain decisions. Who makes a decision? You can have a rules engine, or you can have a agentic workflow that will decide using an LLM, right? So these are the two different options that we have. And then MCP comes along. MCP is a protocol, and it's about how these agents are going to use tools. Because it was very clear that we needed to have a way of accessing my database and GitHub and Notion. My agent had to have all this context to be able to answer my questions. So they came up with this protocol. It's a protocol. Protocols are they have good things and they have bad things. But this is basically an example. We have a user who talks to an agent. The agent uses an LLM and calls different servers that access third parties. This is great, but there are a lot of issues that you will have to deal with this. Right? One of the first, there used to be an image here, it's not here, but one of the issues that I've seen as a maintainer of this repo, where it is, this one, the MCP registry. We have all the MCP servers here, right? And like if I go to Docker Desktop, this is basically the catalog. Then you can come here and then we tell you a little bit of what the server does and which tools has and configuration and blah, 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 right? One of the issues that I've seen with this is that people are building all these MCP servers like we build APIs. And in reality, we should not do that. We should not be that hasty, right? Again, who is the user in this case? We have the user talking to the agent, and the agent is the one launching the MCPs, right? So who is in control? Your MCP returns an error. What happens next? Historically, in an API, you have an error, and then you returns, and then someone has implemented some logic. Here, you have a non-deterministic system that is going to get you error and decide. And might decide to go back to the user, and might decide to do something else. Right? In this example that I use with Gordon, sometimes the tool does not work. And then the agent might decide, oh, I'm just going to do a call command to this, try to fetch information anyway. The user doesn't do anything. I'm just said, do this, I have an error, and the agent deals with that. Which is great, because it gives us an opportunity to do other things, as long as we build the MCPs in a particular way. Right, so when we're building this kind of tooling, MCP inspector, great. It will help you a lot to understand and how to interact with your MCP server AI, of course, or the AI agent. And you will see, oh, the toolkit. Toolkit can help you to debug and to see the behavior of your MCP in certain places. And until very recently, I was using the agentic compose, but now we have, it's going to be announced next week, I think, or not. It's the Docker agent builder, is this thing. It allows you to create agents. So you can come here and say, create an agent that analyzes the something like this, and then I click AI creation, and now we're going to create an agent using AI, and this agent takes a while. I'll come back to this. But we have a way of creating agents that then you can use for other things. Right? One of the things that I want to point is something we call tool budget. And tool budget is important because size matters. The context window size is important. And at some point, having too many tools are too many. Right? I never understood how the cat got there, but I had to put this GIF, sorry. Let me see if this was finished. No. Super slow. But anyway, testing AI systems, very different as well. Why? Because unit testing, when people unit test the MCP servers, what they do is like, do I have this tool that calls Notion? Yes. Do I have this tool that authenticates? And they're like, yes. Is this how people are going to use it? No. How are they going to use it? I'm going to talk to an agent. They're going to say, go to my Notion and give me all these things. And then, right? So unit testing, yes, but integration testing is different. Again, we have a non-deterministic system there. Right? But there's two things that are different here because the schema validation happens in the machine of the user. You will get this JSON file, and people will have to put it in a particular place, and they will not do it properly, and then nothing will work. And they will blame the agent, the tool, or everything. And the other thing is error handling. I'll show you an example of the error handling opportunities that we have. Okay, integration test. This is how I used to do the integration testing. That it was very alpha because it was me doing this, but now deprecated. See, and I'll show you the compose that I had. I was using the agentic compose using Crew AI, but now I use this D agent and C agent because the thing about C agent, let me see. I'm going too fast. So the agent is the UI, is the electron that allows you to generate and do these things. But then we have the C agent, here. And C agent allows me to run the agents. So what I used to have is, this is my compose. This is how I do integration tests in my MCP server. I have my agent. This is basically the agent that I have. It's basically Crew AI. It's Crew and have, if you know how it works, it's basically a Q agent, a QA agent, and then tasks. And tasks are basically the tests. And so the agent is going to run a bunch of tests. It's going to use a gateway with this server and these tools. And I use this model. This model is important because you can use the tool calling. Okay. So now what happens here with C agent, I can have this in my task file or my make file and just run it. And what it does is the same thing, but instead of compose app, it's just run C agent. It's slightly nicer. Okay. So I forgot that I had this slide. So this is what I do. Like I do it with Crew AI, but as you've seen here, you have a lot of different frameworks, and you can use whichever you feel more comfortable with. If you don't know which one, you can come here and test and try different languages, different approaches. You can play. And you can basically run them if you have enough hardware and blah, 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 a bigger board. And this is it. That was what I was doing, basically, my MCP, using the MCP gateway and all these things, trying to still do what we used to do, running tests. I show you this. Okay. Let's see about this. We have two options. When you build an MCP server, you need configuration, you need authentication. You can decide now if you're going to, as soon as the MCP server starts, you're going to connect and authenticate with a third party, or you're going to wait until a tool is called. And then every time I talk about this, I ask this question, and like people raise hands. Who thinks that we should fail early? Who thinks that we should just implement this the way that we have implemented all the other systems? Okay. Well, how many do you think this is the other way? Usually it's 50-50. It's not very clear which one it is. I can show you an example, right, with Couchbase. This is Compose. This is Stubborn Agent. Where is yes. So I have. This is the MCP server that the community has built, and I modified a little bit to make it work slightly different. I have two more tools here, right? So what I'm going to do is to run. Where I am here, MPX. I'm going to run the inspector, and I'm going to run it with the default configuration. This is what you have when you run the Couchbase, right? And what we have is, you can look at the environment variables. They're here. Everything is configured, and I'm going to connect. And basically, it tells you this, right? It's like, okay, whatever you have done here is not working. That's it. I don't have anything else to do. Let's try the other one, which is this one. Same thing, same configuration, exactly the same thing. But now when I connect, it connects. And I can list the tools. So now the agent can interact with your MCP server even the configuration is not correct. And why is this important? Because you can do something like this. And what is this? This is a little bash script that I've created because when you talk to the agent all of a sudden decides, I cannot connect, I have this error, but I'm going to look at how to connect. And it found this tool, and the tool gives you these two things. The tool basically says, look, you can run a Couchbase database by running this Docker command, and you can initialize it by running this series of. And it is not the user who's going to do it, it's the agent. And the agent says, do you want to run it? Press this button. Boom. It works. And so all of a sudden, we have an ability from the server to interact because the agent has the tools. But as a tool creator, I know that the agent is there, so I can leverage that to do things. For example, telling the user how to run it, right? So it's more about the mindset. It's just changing how you see and how you think. So in summary, what we have seen is that AI is moving fast, and we're very early. But you have to drop the tools. If you have spent 3 months building something, then that is not the right thing. Just drop it. You have to learn a lot. All the people that came in the journey with Kubernetes, we had to learn a lot of the things that we thought that we knew how it worked. We had to reinvent them. Right? So the old paradigms might not work. We might have to come up with something new. Right? And security matters. And what is this security important? Like, in the example that I showed you, like we have this gateway. I think that this one will be easier to see. This one, right? Like each server comes from different places. Where here? Each server comes from different places, right? Like how do we apply policies? What is the pattern that we have used historically here? It's an ingress. It's like an API gateway. That's why we have a gateway here. What we have in reality is this gateway. Here is where you can put all these interceptors and blah, 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 right? And this is how you make sure that your agents do the right thing with the tools. Something as that happened, as soon as I saw the MCP, I went to a colleague of mine and said, like, we need to address the secrets problem. Because I don't know if you're very familiar with Docker secrets, but they're not very secret. And it's never been a problem because the boundary was in the cluster. When we presented secrets management, what I'm going to show you now in London, 95% of the people said, I don't care. Because it's in my machine, I trust it by default. But now you have this scenario where you're running all these MCP servers with all these tokens, your Google keys and your Notion keys and all the stuff. And it's like, okay, are you still okay with secrets not being secrets? Probably not, right? So we came up with something that allows you to define a secret, which is basically with this command. I can show you. Make it bigger. So I can do Docker MCP secret less. And I have a few. And I have this one. This one is basically this one, right? But now I can run this container, and the only thing I do is to specify this label, right? And then in Postgres you can say what your password is by doing this, right? And then Postgres stats. Oh, so we have Postgres here. And now I can do Docker debug. And now, if we do this, I don't have access. And you might say, oh, it's because you're not the right user. Yes, I am. You should be able to do it. Right? And it works with debug or with Docker exec, or even if a container tries to jump and steal that secret. Only the process that runs the container can read that secret. Right? So we have a way of protecting this. It's like, okay, this is good. It doesn't work with environment variables. I don't know if we will be able to do it, but these are the kind of things like, okay, these things that were okay now in this new world are not okay anymore. Now we have to deal with this. Right? And I can show you with exec containers. This one, exec, something cat. Permission denied for my root. Right, so like it doesn't matter how you try to get into this, the secret is protected. So you have a way now. It's a responsibility of the creator of the container to do it and use it in this way. But in reality, the only thing you have to do is to read the secret from a file instead from an envar, which is something in Kubernetes we do, right? And when you run it, you just need to specify this. And by doing this, as long as you have the secret, as long as you have the secret defined, you will be able to inject it, right? So we're building providers with Vault and with all these other things, but you see the gist, right? It's like we get value of a secret that injected in the container and we make it safe. And so yeah, like all these things that didn't matter before, now it matters. The thing has changed. And that's all for me. Thank you.